So we now want to talk about an important component in STL. It's called iterators, and we've seen some examples already, so it's not a complete strange topic for you at the moment. And basically we would like to discuss all the different categories of iterators and what you can do and so on and so forth. And it's a global overview, but in practice I reckon you use about 20% of the iterators that you need, and they're all embedded in the containers you need. So let's start. So the categories, the main functionality, and integrating or combining containers and iterators. So what is an iterator? An iterator is an entity, it's an object, which will allow you to access and traverse the elements of a collection. So you've got a vector, you want to get the values from it and read from the beginning to the end of the vector, possibly whatever. And the nice thing about STL is the collections you have, maybe STL containers, as we've seen already. So STL containers like vector. They can also be regular C arrays, which you learned in the C course. So you can actually iterate over C arrays if you want to. It's not something we're going to do in the course really, but you need to know how to do it more or less. The I/O stream, the input-output stream, you can actually iterate over the I/O stream using iterator adapters and whatever. Again, we will not talk about the regular iterating over regular arrays and or I/O streams in that sense. So I'm not going to ask you any questions. It's the 20-80% rule. It's nice to know, but basically I would like you to learn pretty well the STL containers and the corresponding iterators. Okay. It is so that when you've got an iterator, it's only pointing to one place at any one moment in time in your collection. It could be pointing to 0 or a null. It could be outside your range, but it's only pointing to one place. So it's like a pointer. And again, you know about pointers, about dereferencing, using the pointer syntax. Many of the operators are overloaded in the iterator class, so you can actually use it as like a pointer. So it's got the look and feel of a pointer. And in general, the iterators are the interfaces between the algorithms on your containers. So let me just draw a diagram again. It's like a mediator. Okay, so here I've got my containers. So I might have a vector with numbers in it, you see. Dots represent numbers. And I've got an algorithm. So for example, count. One of the algorithms we'll be talking about is count the number of elements in a vector or a list or anything. Now if I wrote my count algorithm to directly interface to a vector with all the low-level details of vector, if I want to use the same algorithm code, let's say, for lists, let me draw a list here, I would probably have to draw the code and rewrite the code and copy the code and write the count so it works with lists. So it's a never-ending story. This is not really what I want. What I want to do is that my count does not talk to a vector in the code, but it talks to an iterator. So it talks to an iterator with a beginning, and it talks to an iterator with an end. So it goes from the beginning to the end. And at runtime, the code in your main program will actually use a vector, for example, to implement the iterator. So your algorithm code is shielded from the specific vector classes. This is a vector class. This could be a list class. So it'll all remain the same. Okay, I hope it's a bit clear. And that's so you just get it works with the so-called iterators. We see some examples in a moment. There are different kinds of iterator value types. So a dereferenceable means just like pointer dereferenceable, the pointer points to an element and it can be dereferenced to give you the element in the data structure or in the collection. Past the end, it's at the end, so the pointer can point to the last element in your data structure, so it doesn't point to anything. You've got singular iterators like a null pointer, it points to nothing. So for example, what you need to know in the short term is every container has an iterator, a function which returns an iterator, and it's called begin, and the other one is called the end. Now, different categories of iterators: trivial iterator, so it's got nothing, it just can be dereferenced. The input iterator reads one element at a time in the forward direction, so we've seen this already. The output iterator is a write iterator, so you can write the elements of the or modify the elements of your container in the forward direction. And forward is a combination of input and output, so you can go forwards and read and write. Bidirectional means it's a forward iterator plus the ability to travel backwards, so you can go backwards with the minus operator. Random access, so you can, it's bidirectional of course, and you can jump to an arbitrary position. So here's the hierarchy which I've shown you already. Now the trivial iterator, maybe I can just skip this point here because it's not so but let me just show you the syntax. So here's a default constructor of an object of an iterator. I can dereference it. All of these operators are implemented. So X will be typically an iterator. So what can you do? You can dereference it, and you can dereference and assign it to a value, and you can access the members of your iterator. Of course, we got the for iterators. You know this from your C course. I means advance one element and return I new value, the new value of I, and I++ advance one element and return the previous value. Input iterators, these are read-only iterators. We've said it's like a refinement of a trivial iterator. It only goes in the forward direction. So the last two remarks are not so important just yet. And what can you do with input iterator? You can have a read-only reference to an element at I's current position. So the iterator is pointing to something. If you dereference, you get the value. You cannot necessarily change it, and we see in a moment why. These are const iterators in a moment. You can check if two iterators are equal or not equal. So the iterators may be moving up and down in your collection. You can actually check if they are equal. This is like comparing pointers, as we've seen before. Output iterators write values into a sequence. You cannot read, and yeah, you've got assignable and default constructible. So in other words, you can assign output iterators to each other and construct them using but just a default constructor. They only go in the forward direction. So just forget about the last two remarks as well. So an output iterator, I can dereference the iterator, in which case I will return a writable reference to the element at the current position, and I can set one iterator to another iterator. So the forward iterators are just input and output iterator in one direction, and the bidirectional iterators can travel in the forward direction and in the backward direction. Okay, and bidirectional iterators have, of course, since they go in the backward direction, the operators minus as before. Random access iterators you got in the vector class. In other words, the whole point about it is with a bidirectional iterator, you can position anywhere in the sequence. Okay, so here are the operators which are supported by random access iterators. It's like operator overloading. Advance by n location, return I's new value. So the iterator is advanced n positions in one go. Or you retreat n positions and you give the new value of the point of the iterator. Return an iterator, so you have j is equal to I plus n, so it's a new iterator. Or return j equals I minus n. So you can actually shift your iterators in real time. The iterator I return a reference to the nth element of the associated collection. So this is a way to actually access the elements of a collection. With random access iterators, you can actually compare if I's position is less than J's position. So you can actually compare the iterators. Now here's a very good example of which you should, I would advise you to type it in, because it's got everything we need to know in the short term about iterators. So it's a good test. I'm not going to do any demos today, but this will be the specific example I'm talking about. Okay, I've got a list and a vector. I will have a corresponding iterator for a list and an iterator for a vector. But what am I doing? I'm doing the following. I'm creating a list which is empty in the beginning, so it calls the default constructor here. I'm creating a vector with 10 elements. The elements are initialized to 0 presumably. I push some data onto my list. I create two iterators as before, and the values, the iterator in the list goes to the beginning of my list, and the iterator in my vector goes to the end of my vector, at the beginning of my vector. Now here's the real meat of the example. While my iterator IL, while it's not at the end of my list, so I copy everything from the list, I actually post increment my vector iterator. You see, I dereference it and I assign it to the dereference value of my iterator to my list. In other words, I copy the values from list to vector. It's a very long-winded way of doing it, because later on we'll see you can just copy, use a copy algorithm. But the point is, it tests your knowledge of iterators and containers, of course, and also your knowledge of increment operator and also dereferencing. So this is a good way to test your knowledge, to see how it works. And just to prove that it works, I print the vector. I go, my iterator is assigned to the beginning of my vector. While it's not equal to n, I just increment and I dereference. As you see, it's dereferenced, and I print the value. So the exercise will be it's got twice. Hold on. Okay, so we're finished. It's a double here. Just let me delete it. Okay. So the summary is the following. We give an example, the introduction to iterators in STL. So basically, the examples you've seen are more or less enough for the moment. So believe me. So iterators are pointer-like objects which can be used to navigate in containers. And the types are the input iterators. These are forward read only. Output is forward write only. Forward is read and write. Bidirectional, can go in either direction. And you've got random access iterators, which you have in vectors, for example. And you need to know about the pre and postfix stuff, plus, plus, minus, minus. And we have excluded a discussion of the IO stream iterators and the adapters, and iterating over C arrays. Which iterators can you use if you wish to compute the sum of elements in a list? So how are you going to compute the sum of elements in the list? Iterators hide implementation hiding details of containers. What does this statement mean? Explain the relationship between const objects and const iterators in your code. You're going to get some problems here. You might, because if you've got a function like a print, let me give a demo. Why not? I'll go back to a previous demo, because it's I must say, a lot of people don't use const, which means that a lot of things aren't going to work. People don't use const for a number of reasons, mainly because they've made a mess of their code, for example, or they just can't be bothered learning to do it properly. Here's the example. No, it's the wrong example. It's a different project. Sorry, just bear with me. Oh yeah. We talked about sequence containers. Okay, so I'm now going to open my project. Okay, yeah, it's maybe, oh yeah, here's a good one. It's exactly what I want to say. I've got a print function which is a const reference to a vector. You know what this should mean by now. And I've got a const iterator here, you see. So it means the following: when I dereference, my iterator is pointing to an element of L, to the list here, the vector, which means you cannot change it. So everything works okay. We've tested it already. But let's say I had a normal iterator. I'm going to copy the code first of all. Just to show you some of the nasty things which happen and people get frustrated and so on. But you're doing a course here, so we're prepared for errors. And okay, so I'm just doing a normal iterator. This is an output iterator now. The const iterator was an input read-only iterator, which means potentially I can be changed. So let me see what happens. You're saying potentially you can change the value of the dereference value of I, but on the other hand you're saying the object to which it's pointing is const. So you've got a problem here. One moment you're saying it's const, the next moment it's not const. So let's see what happens. Please make an error. Please. Oh yeah, it makes an error. Some people say please no errors. I say please error. Okay, no such file or directory. That's a completely different problem now. That's really weird. I don't understand this. Let me go back to my original code. It worked yesterday. Of course, that was Friday. Okay, so let me run it again. Maybe there's something else. Oh dear. Okay, so that's really strange. I wonder what the problem could be. So I'm going to do the following in real time. I'm going to remove my, you obviously can't find it somewhere. I'm going to remove, oh, I know where it was in directory number 6. I put it in number 4, but it was directory number 6. So I'm going to remove it from my directory, remove, you see? I'm now going to go to directory number 6. Here's my directory number 6 now. I'm going to add it, yeah, sure, I'm going to add it to my project. It should really be project number 6, but anyway, okay. I hope it works now. Wow, it works. Okay, so if I now change it to a normal iterator, this is going to go wrong, because going back to where we started before, just let me get rid of some stuff here. Okay, so we're saying it's a writable iterator, but your object is const. It's going to give a compiler error. It just doesn't work, because you're saying it's read only, and then you're saying you can write it. So it's you get all sorts of rubbish, you see. Oh dear, oh dear. There is no right hand side of operator const blah blah blah. So you have to think about life and realize that if you've got a const object, you have to have a corresponding const iterator, of course. Oh. So I just go back to my original example. It's a bit difficult here with Camtasia. It's jumping all over the place. Okay, so let me rebuild it again just to make sure everything was okay. So be careful with const iterators, that's what I'm saying, and const objects. Oh great, so it works now. So we'll take a break now. We're finished with the iterators. So I'll see you later. Bye.